Hi, I'm Norman Wildberger. Today we're going to look at a particular problem in rational trigonometry concerned with a triangle, a vertex bisector, and a median. This problem will give us an opportunity to review and practice a number of basic techniques from rational trigonometry. So we have a triangle whose side lengths are 6, 7, and 8. We're given this line here, which is a vertex bisector, or angle bisector if you like. And we're given this line here, which is a median, so that these two lengths are the same. And what we have to figure out is the distance between this point and this point. So first we convert the information into rational trigonometry into quadrances. The quadrances are 36, 49, and 64. We then have the basic strategy that we're going to solve things one triangle at a time. So we solve for one triangle, get some information that we then use for an adjacent triangle. And we work from what we know towards what we want. Okay, so what we're going to start doing is find one of the spreads of the triangle. The spreads are S1, S2, S3, and we'll find the spread S3, which is the spread between this line and this line. That's given by the cross law. So there's the cross law there involving the three quadrances and the spread that we're trying to find. We solve that, we get 15 over 16 for the spread S3. Now we're going to try to find the spread S. And this spread together make a spread of S3. And so the relationship between S and S3 is that 4 times S times 1 minus S equals S3. This is the second spread polynomial, otherwise known as the logistic map. Now this has two solutions. It's a quadratic equation, and you solve that. You find 3/8 and 5/8. And then you have to choose which one of those two you're going to take. And we're going to take 3/8 because 5/8 is bigger than a half. And if this was bigger than a half and this was bigger than a half, then the whole spread there would be obtuse. But it's actually acute. That spread is acute, and we know that because 49 plus 36 is bigger than 64. That means that sector is an acute sector, and so that spread there must be less than a half. A half is like 45 degrees. So now we have the spread S, which is 3/8. Alright, so continuing on, we've talked now about this vertex bisector. Let's talk now about this median. The quadrants of a median is given by a very nice formula. It's shown to you in Wild Trig 18 in this series. So this quadrant here is 2 times this quadrant plus this quadrant minus this quadrant, all divided by 4. And so we know all these three, so the median's quadrants is 95 over 2. And now in the triangle A3CA1, this one right here, we can apply the spread law. The spread here, which we're calling R, divided by 49, is equal to the spread here, which was S3, or 15 over 16, divided by this 95 over 2 that we've just found. So that's the spread law in this triangle here. That allows us to solve for R. So now we know that the spread R is 147 over 152. Okay, now we're going to look at this triangle here, because ultimately we want to know this quadrant here, and then that'll help us with this triangle here aiming towards what we want. So we're going to analyze this triangle, and the first thing that we need to do is we need to find that third spread. We know one spread of 3/8, another spread of R. So the triple spread formula is going to give us the value of U. There's the triple spread formula in sort of standard form. It's a quadratic equation in U. And here's an alternate version of that, which is preferable if you want to solve for one of the three spreads. So it's U minus, there's one spread, plus another spread, minus twice the product of those two spreads. All of that squared is 4 times 3/8 times the other spread. Here the product of the two spreads. And here are the products of 1 minus those spreads. So 1 minus 3/8 and 1 minus this one. That's a rewriting of the triple spread formula, an equivalent formulation. And now it's a quadratic equation that we can solve. We can solve for u. And there's going to be two solutions, and we observe that 3/8, this spread and this spread r, are both acute. This one's kind of obviously acute, but this one is acute because in this triangle, this quadrant plus this quadrant is bigger than 49. 9 plus 95 over 2 is bigger than 49, so that's actually an acute sector there. That'll help us figure out which of these two solutions we're going to take of the triple spread formula. So that quadratic equation for the triple spread formula simplifies to this thing here. And conveniently, the right-hand side is a square. So pleasantly, we get two rational solutions. And the triangle spread rules tell us that in such a case, we need to take the bigger solution because both of these values are acute. The bigger one is 15 over 19, and so that's our value of u. Good. Now we can analyze this triangle here to figure out what the quadrant's p is. 3/8 over p equals u over 9. That's the spread law. Solve for p. Get p equals 171 over 40. And now we're down to our final triangle, this one right here. We're after this quadrant's q. We know p. We know this is 9. We know this spread also. It's the same as this spread. So the cross law in this triangle is this one right here. The cross law, which has two solutions. Again, pleasantly, they're both rational numbers. And which one do we take? Well, we have to ask ourselves, what about this spread? Is this sector on this side obtuse? Yes, it is, because we've already noted that this one is acute. So this one's going to be obtuse. So there's two possibilities, and we need to take the bigger possibility for q. The bigger possibility is this one right here. And so that's the final answer for q. That's the quadrants of the segment that we're looking for, and its square root is the distance. So that's our first problem. Quite a lot of different aspects of rational trigonometry figuring in that. There's also another way, quite a different way of solving this problem. And next time I'm going to show you how to use barycentric coordinates to give a simpler derivation of this answer. I hope you'll join me for that. I'm Norman Wahlberger. Thanks for listening.